This is R.D. Sharma solution, class 12, chapter 19. Exercise is 19.19. Indefinite integrals we are talking about. Now in this question we have this numerator cos x dx. This we can get from sin x. Then we have a cos square x in the denominator, so we need to convert it into sin x so that we have a homogeneous sign in the denominator. So I'm writing this cos square x as 1 minus sin square x because sin square x plus cos square x is 1. Then this 4 sin x. Now let's change it, 5 minus 1 plus sin square x minus 4 sin x. Now let's rearrange it, sin square x minus 4 sin x, and 5 minus 1 is 4. So now this denominator, if we place t equals to sin x, this dt by dx will be equal to cos x. That means this dt will be equal to cos x dx. So the numerator we have got. So now this integration in terms of t will be like this. 3 sin x minus 2, 3 sin x is t, so 3t minus 2 divided by cos x dx is of course dt now. So you can write dt straightforward. If you take this sin x as t, so it will be t square minus 4t plus 4 because it is actually sin square x minus 4 sin x plus 4 which we have changed. Now we'll try to represent this 3t minus 2 in terms of t square minus 4t plus 4 differentiation. So 3t minus 2 can be written as a and b constant but with the differentiation d by dx of t square minus 4t plus 4. What is the differentiation of this t square minus 4t plus 4? It will be 2t minus 4. So I'm just trying to reduce the steps because of the scarcity of the area. 3t minus 2 equals to this already we have done d by dx, so just multiply this now a with 2t minus 4. It will be 2at minus 4a plus b. Now just equate it. 2at will be equal to 3t. So when 2at equals to 3t, there will be another equation being formed. Minus 4a plus b is equal to negative 2. So just cancel this t. So a will be equal to 3 by 2. So let's write a equals to 3 by 2. Now put this a equals to 3 by 2 here. Negative 4 into 3 by 2 plus b equals to negative 2. So b will be equal to c. 2 2s are 4, negative 6, it goes here. 6 minus 2 is 4. So a is 3 by 2 and b is equal to 4. Now this in the equation we are putting here, basically we have converted the numerator in certain form so that we can separate it with the denominator and we can get a proper integral out of it. So this integration will be something like this. So a into 2t minus 4, a was 3 by 2. So let's take this 3 by 2 outside. 2t minus 4 here, first thing. What is the denominator? It remains the same. T square minus 4t plus 4 in terms of dt. Then we have this second one, which is b, which came to 4. The 4 I am taking outside, integration of dt divided by, of course, t square minus 4t plus 4. Now this is I1 and let's call it as I2. We will separately integrate them and then we will combine them. I1 is, if you take this p, some p or u you can take, any letter. P equals to t square minus 4t plus 4. dp by dt, what will come? It's 2t minus 4 which has already been done. So dp will be equal to 2t minus 4 into dt. So this numerator 2t minus 4 into dt will become dp. A constant I'll deal later 3 by 2, but this will be dp. Whole numerator will be dp. Denominator will be what? It's p. So dp by p is a log modulus of p plus constant of integration. What is p here? We took p as t square minus 4t plus 4. So let me write it, t square minus 4t plus 4 plus constant of integration. Let's call it as c1. Now t was sin x. We took t as sin x. So it will be log 3 by 2. I am not taking it because we have finally arrived at the I1 solution. So this whole I1 I am writing, 3 by 2 is there, log, replacing t by sin x, sin square x minus 4 sin x plus 4 plus constant of integration c1. Now this sin square x minus 4 sin x plus 4 is what? It's sin x minus 2 whole square. You just square it, sin x minus 2 square. You will get this sin square x minus 4 sin x plus 4. So if you want, you can just write it as sin x minus 2 whole square. Or it can be 2 minus sin x whole square also because negative It doesn't matter if it is square. When you have this log, if you have any base and any value of log with certain power, you have a base and you have an exponent. So this power will come in front. So 2 will come in front. Sin x minus 2 whole square, 2 will come in front. So 2 gets cancelled. So it will be only 3 log sin x minus 2. Or you can write it as 3 log 2 minus sin x. As I told you, that square doesn't matter. Before taking 2 outside, you can just convert this into 2 minus sin x. It's up to you. But this is also true. Next one is t square minus 4t plus 4. Now you want to make it as a perfect square? You don't want to, because it's already a perfect square. It's t minus 2 whole square. T square minus 4t plus 4 is already t minus 2 whole square. So this t minus 2 goes up. We are going to integrate it. T minus 2 to the power negative 2. So t minus 2 to the power negative 2 plus 1 divided by negative 2 plus 1. This will be t minus 2 to the power negative 1. And this is negative. So it will be minus 1 by t minus 2. What was t? What was t? It was sin x. So now this you can write. 4 I have already taken because this was initially there. It is negative 1 by t minus 2. Or you can write it as 2 minus t also. If you want to just separate this or avoid this negative, then just convert this t minus 2 into 2 minus t. So the negative will be forgotten. 4 divided by 2 minus sin x. So I1 plus I2 now I am doing. I1 we have got, I2 we have got. So we can just combine this and add this. Please remember 3 by 2 and 4 has already been incorporated. So I will be equal to, this is 3 log modulus. As I was telling you, you can write it as sin x minus 2. You can write it as 2 minus sin x. Just because the I2 has came to us as 2 minus sin x, you can change it, or either you can keep it like that only. That's why I was telling you that you can just reverse this or swap these two terms in order to match the I2 also. What was I2? 4 divided by 2 minus sin x. So you can make it symmetric, writing both as 2 minus sin x or both as sin x minus 2. It's up to you. So this is your final result. Okay. Now whatever we have discussed is in front of you. And this was a different kind of question. That's why I explained you it in detail. Anything which I missed, you can just take it from here and try to solve it by yourself. Now this question, I'll just go ahead because this question has already been done, or this type of question has already been completed previously. So this you can see, you can just try yourself. Same here, 5x minus 2, you can also do this because we are on 12th question. So we have completed 5-6 questions like this. I have properly solve them for you, so you can just refer it here, try to solve it. Any problem you can just comment. Same thing here, there is no change here. Now this question, now you will be tempted to do it exactly like the previous question we have just completed, but this question is a bit different. First let us resolve it and then try to find out what we get, because simplification and resolving will make it easier. Otherwise, the same process if we follow, maybe we won't get the result we desire. So the denominator I am writing cos square x as 1 minus sin square x, because you know sin square x plus cos square x is equal to 1. Now just open the bracket, 13 minus 1 plus sin square x minus 7 sin x. Now rearrange it, sin square x will come first, then 7 sin x, 13 minus 1 is a 12. Okay. So you can now make a perfect square or the factors out of it. But factor will be what? Negative 7 sin x can be written as negative 3x minus 4 sin x, because it's negative 7 sin x only. Take the sin x common, it will be sin x minus 3. Now take minus 4, negative 4 common from here. When you take negative 4 common, it will be sin x minus 3 inside. So the two factor or two terms which has come are sin x minus 3 and sin x minus 4. So basically the denominator, we started with certain thing and now we have come to the factor. That's what we wanted. Now take t equals to sin x. dt by dx will be equal to cos x, because there is cos x dx in the numerator. dt has become cos x dx. So cos x dx can be easily replaced by dt now. So the final integration or the integration with this all changes, let me write it. This 3 sin x minus 2 will write it as 3t minus 2. Cos x dx was taken as dt. The denominator will be sin x minus 3 and sin x minus 4. So just write it t minus 3 and t minus 4 because sin x was taken as t. Now how to represent this 3t minus 2 in terms of t minus 3, t minus 4? Now what certain students will try, I'm just trying to show you, and where the problem will arise. 3 minus 2 has to be represented in terms of t minus 3 and t minus 4. Either you have to add t minus 3, t minus 4, either you have to subtract, you have to add certain numbers in order to match it with 3t minus 2. For example, if this t and t is there, in order to get a 3t, you have to add a t and subtract a t. So I'm adding a t and subtracting a t. This negative 3, negative 4 will be negative 7, but we need negative 2. So you have to add a 5. That means you have to add a 5 and subtract a 5. So plus 5 minus 5 you have to do here. So those who want to do it like this, they can also do. So we have t minus 3. So 3t has come, and all others will form, they see, separate them. 3 minus 2, just separate them out. Whatever is remaining, it's negative 4, negative 3 and negative 5. So there will be a term, negative 12 is coming. So you can do that. But the idea of doing this will not solve our purpose, or will take us to some new route which we don't want to travel. So I'm not doing it like this. The better way is to do it like this. 3t minus 2, we need to separate them out. T minus 3 and t minus 4 separately. So 3t minus 2 by t minus 3 into t minus 4 can be written as a by t minus 3 plus b by t minus 4. You can always do that. So just take the LCM, a into t minus 4 plus b into t minus 3, b into t minus 3 now. 3t minus 2, denominator will be t minus 3 into t minus 4. So t minus 3 into t minus 4, denominator also here on the right hand side will be t minus 3 into t minus 4. This denominator gets cancelled, so you have to equate 3t minus 2 with t minus 4 into a. Let's multiply it. At minus 4a, bt minus 3b. So I'm adding at and bt, and negative 4a from here and negative 3b from there. So 3t will be equated with the similar term which is a plus bt. The second equation will become negative 4a negative 3b equals to negative 2. So negative 2 can be equated as minus 4a minus 3b. From here a plus b equals to 3. Now you can just take a as 3 minus b or b as 3 minus a and put it in the equation number 2, which is on the right hand side. So negative 2, I have taken a as 3 minus b, so negative 4, 3 minus b plus 3b. So negative 2 will be negative 4 is a 12 plus 4b minus 3b. So this will be, b will be equal to 10. A is equal to 3 minus 10, which is negative 7. A is negative 7, b is 10. Now this 3t minus 2 divided by t3 minus t minus 3 by t minus 4 can be directly written as a by t minus 3, that is negative 7 by t minus 3 plus 10 by t minus 3. So I'm separating them into two terms. So first is a by t minus 3, a is negative 7, I'm taking negative 7 outside, dt by t minus 3 will remain like this. The second term is b by t minus 4, b is 10, so 10, and this is t minus 4, so you have dt by t minus 4. Now there is a direct integration of this, okay? It's simply negative 7 log modulus t minus 3. What is t? Sin x minus 3 plus 10 log, again t is sin x, so sin x minus 4 and plus constant of integration. So this is your final result which I am showing you here. This will be the final result. So here I told you what not to do and then took you to the path which is the correct path. This was the wrong track which I took intentionally. Okay, this is the way we are going to go about it. There are certain ways which you can do. One of the way which I told you, but there are certain other ways which I tried to show you, and you can follow that scheme also. Okay, this question I will just go past it because you already know how to do this. Okay, this is a different kind of question because it's x cube. You can write x cube as x square into x. Now when you take this t as x square now, dt by dx will be equal to 2x. So you have got x now. Dt by 2 is x dx. X dx is already in the numerator. So this x dx is numerator dt by 2. So the integration will become like this. 1 by 2 I am taking dt by 2, that is dt is here. 1 by 2 I have taken outside. X square you have taken as t, so you can just put t in the numerator. X raised 4 is t square whole square. X square whole square is t square. X square already taken as t plus t. So this t needs to be represented in the form of t square plus t plus 1. So t will be in the differentiation. So a into d by dt of t square plus t plus 1. and then we have a constant b here. So this t will be equal to a. What is the differentiation? T square plus t, it is 2t plus 1 plus capital B. Now this 2at plus a plus b, this is equal to t. Now equate the similar terms. T equals to 2at, and the second equation will be a plus b equals to 0, because there is no constant term on the left hand side. So a becomes equals to negative b. Whatever a will come, b will be negative of that. So a cancels here, a is half, so b will be negative half, because they are opposite in sign. So this integration, if we take this equation which I am pointing number 1, so half in place of a, half is already there outside. Please remember, it was in the previous I which I showed first time, half was already there. So let's take this half outside. Now this is half. So half, you can take half common from inside also, because there is half and negative half. So half comes out, 1 by 2 was already there, so 1 by 4 comes. So we have got rid of all the constants now. So 2t plus 1 divided by t square plus t plus 1. Just witness this equation number 1. I'm just writing there only. And then in place of b, I have taken negative half. It goes, half goes out, 1 by 4. Only remains this dt by t square plus t plus 1. So this is I1, and we regard this as I2. We will integrate them separately and then we'll combine them. So let's take p equals to t square plus t plus 1. dp by dt will be equal to 2t plus 1, which we have already done. So dp will be equal to 2t plus 1 into dt, which is the numerator here. So this dp integration, and this is p. It will be log modulus of p plus constant of integration. What was p? It was t square plus t plus 1. And what was t? It was x square. You can write directly, or you can take one step to do this. So t square plus t plus 1 plus 1. And initially I told you t was x square. So the original equation in the denominator, which is x raised 4 plus x square plus 1, will come here. So log modulus x raised 4 plus x square plus 1 plus constant of integration, which you can write it as c1. 1 by 4 is already there. We'll take it later. I2 is what? It's dt. And t square plus t plus 1 has to be made as perfect square. What is the coefficient of t? Which is 1, divided by half, which is half. Square it and add it and subtract it. So I'm adding half square and subtracting it. So a square plus b square plus 2ab, t plus half whole square. 1 minus half whole square is 1 minus 1 by 4. That is 4 minus 1 by 4. That is 3 by 4. So this will be plus root 3 by 2 whole square, because 3 by 4, if you want to square it, it will be root 3 by 2 whole square. So this will be plus. I've written a negative. I'm making it as a plus now. So t plus half whole square plus root 3 by 2 whole square. You already know what is the solution or the result of this. It will be 1 by a tan inverse x by a. T plus half by root 3 by 2. Now t plus half can be written as 2t plus 1 divided by 2. Root 3 by 2 is root 3 by 2. 2 gets cancelled. 2t plus 1 divided by root 3. So this 1 by root 3 by 2 goes 2 by root 3 tan inverse. 2t plus 1 divided by root 3. What is t here? 2 by root 3 tan inverse t. Now you can just jump into x square now. T was initially x square. So write it as this one. So 2x square plus 1 divided by root 3 will come. It's root 3, not 3. So just change it. And since the negative is here, just write negative sign. I'm just trying to combine with this I1 and I2 here only. So this will be I1, which is log modulus x raised 4 plus x square plus 1, and this constant of integration c1 and c2 will combine as constant c. So this is your final result, final integration. We combined I1 and I2. So this is how we are going to go about it, the same way which we have done the previous questions. Only x cube can be written as x square into x. Now x cube minus 3x by x raised 4 plus 2x square minus 4. Now you would like to separate them out, x cube by denominator minus 3x by denominator. But there is a little hint. The hint is, if you just take this x cube minus 3x in the factor form, this will become very easy to you. That means x cube minus 3x can be written as x into x square minus 3. This x square is already in the denominator, and this x we can get it from when we take this something from the denominator. That means t, I am taking it as x square. dt by dx will be equal to 2x. This dt by 2 will be equal to x dx. So this x dx, when we separated this x cube minus 3x in the form of x into x square minus 3, so this x dx is dt by 2 I have taken outside, x square minus 3, x square was t, so t minus 3 will come. Denominator will be x square was taken as t, so it will be t square plus 2t minus 4. Now again, this t minus 3 has to be represented in terms of t square plus 2t minus 4, but we have to differentiate it. But one more thing is there. If you multiply 2 to numerator denominator, this 2 into t minus 3 will be 2t minus 6. What is 2t minus 6? I am taking a different step. You can take the previous steps like which I explained you. Just t minus 3 equals to t dA into d by dx of this denominator plus b. But here, if you multiply this numerator denominator by by 3 or 2, so it will be 2t minus 6. But 2t minus 6 can be written as 2t plus 2 minus 2 plus 6. That is, the numerator 2t minus 6 can be written as 2t plus 2 minus 8. But the only thing is that this 2t plus 2 is the direct differentiation of t square plus 2t minus 4. So rather than doing that t minus 3 equals to a into d by dx of t square plus 2t minus 4 plus b, we directly have 2t plus 2 minus 8, which is actually what we have got after multiplying numerator denominator by 2. So this is a different approach. 1 by 4 is already there. 2t, I am now separating out 2t plus 2 divided by t square plus 2t minus 4 first term. Now this minus 1 by 4 into 8. So 4 and 8 will give you 2. So 2 integration of 1 by 4 was multiplied to the first term. 1 by 4 was multiplied to the second term where 8 was there. So 4 and 8 has given us 2. That's 2 has been taken out. So it will be dt divided by t square plus 2t minus 4. Now integration of these two terms you already know. You can just go about it. You already know how to do this. But let's for the completion do it. Let's take t square plus 2t minus 4 equals to p. And since we have done this 2t plus 2 minus 8 in order to get this term, so 2t plus 2 was essentially got from there, and which is actually the differentiation of p. So this p taken as the denominator has got us numerator. So 2t plus 2 into dt is dp only now. So dp divided by the denominator which was taken as p. So it's simply log modulus of p plus constant of integration, call it as c1. So log modulus of what is p? T square plus 2t minus 4 plus c1. But t was initially x square, so you can write it as log x square whole square x to the power 4 plus 2x square minus 4 plus constant of integration. 1 by 4 is already there. This is the first term we have already done. Coming to the second term, negative 2 will deal later. T square plus 2t minus 4. So 2 divided by 2, it will be 1. Square it, add it, subtract it. So I am adding 1 and subtracting 1 in order to make the denominator as a perfect square. So this will be a square plus b square plus 2ab, that is t plus 1 whole square. Minus 4 minus 5 will be negative 5. So you want to make it as a perfect square. So just make it as root 5 whole square. So negative 2 will deal later. This is dt divided by t plus 1 whole square minus root 5 whole square. Alright. So what we got, I just explained you. I2 we got as integration of, constant will deal later. It's dt by root 5 whole square minus t plus 1 whole square. Since negative was outside, we have just changed the sequence of the term or swap the sequence of the term in the denominator. So it will be 1 by 2a ln x minus a by x plus a plus s by a minus x. Since a square minus x square will give you ln root 5 plus t plus 1 and root 5 minus t minus 1. Okay. So this will give you this 1 by root 5, 2 gets cancelled, ln root 5 plus t plus 1, write it as x square plus 1. And this will be root 5 minus x square minus 1. So there is a slight change in the sign, you can do it by yourself. And this I1 was what? So I am just adding I1 here only. So just making a step easier. 1 by 4 ln, this already done, okay, previously, x square plus 2x square minus 4 plus, I told you it was a negative, and since negative I have taken inside and swapped the terms t plus 1 whole square with root 5. That's what this has come. So how to do this question? This is what you can get, and you can solve it by yourself. You can take it as p or u only the term which has any similarity with the present terms you cannot take. Okay, this is all about this exercise. Thank you so much and have a good one.